Now, in a scenario like this, we have 3 different states we're managing, and they're all kind of related, if you're honest. They're all related to us interacting with an HTTP request. Our user ingredients change whenever we send a request because we either loaded data or we deleted data or we added data. And we're waiting for this request to be done right before we change user ingredients, or we might also have an error. So these 3 states are actually closely related. We're managing them kind of independently, but also we sometimes update 2 at the same time. Like here, where we set error and set is loading right after each other. Thanks to React's batching mechanism, that's no problem, it works just fine. But still, it might be a bit annoying to manage these states independently. By the way, that would get worse if one of the states would depend on another state, which arguably kind of is the case already. When we set our ingredients because we added a new one, we're depending on our old ingredients. It's not really a different state, we're not depending on loading or error here, but it's an older snapshot of the same state. So in such cases where you depend on the older state, or you need to update new state based on maybe also some other new state of another state object, then there is a better way than using useState. You can instead call or use usereducer, another built-in hook. Now, if you followed through the Redux section, the word reducer already tells you something. Reducers are functions that take some input and return some output in the end. And usereducer uses that to give you a clearly defined way of defining state changes and state updates, and it will then also manage that state for you. So React will do that. It all starts with you defining a reducer, and you typically do that outside of your component so that this reducer function isn't recreated whenever the component re-renders, because the reducer function often is decoupled from what's happening inside your component actually. So here we can have our ingredient reducer, let's say, and we'll actually build 2 reducers, by the way, but let's start with the ingredient reducer. And this in the end stores a function. This function will automatically get 2 arguments passed in by React. The state, and you could name it state, but I'll name it current ingredients. So the ingredients currently stored by React, and an action. That action will become important for updating the state. Now, you also know that concept of actions if you watch the Redux section. An action is an object which could have a type, and then we can use a switch statement to define different cases for different code we want to execute for different types of actions we're getting. For example, we could have a case to set our ingredients. We could have another case for adding an ingredient, and we could have a third case for deleting an ingredient. Now, these are all just identifiers I came up with. You can use any identifier you want. You typically also should have a default case here, but we should never reach this, so here I'll just throw a new error. Should not get there, because we should actually handle all cases that we can have. Now, a reducer, as I said, needs to return something, and will return different things for all these cases. Here we throw an error, which also, well, cancels this function. Here we're not returning an error, but we return something new, and that should be our new ingredients. Now, if we call set, then I want to override my current ingredients with a new list, a new array of ingredients, and that should be part of the action object I'm getting. So there I expect to get an ingredients property, which should be an array of ingredients which will replace the old state. Now, in the add case here, we also want to return a new state snapshot. And our state here is an array, right? Because ingredients is an array, so we should return an array. But here, of course, it should be our old array plus the new item. So the logic is the same as we have it in our add ingredient handler in the end. There we copy our old ingredients, then we add a new one. So here in add, I copy my old ones, which are the current ingredients here, which I get automatically. And then we add a new item, and that has to be part of the action we're getting. And now it's up to you whether you expect to get that all already merged into one object on the action, like ingredient, or if you got 3 different properties. You will be the one dispatching these actions later, so you can decide which data is in there. And here I expect to get my ingredient in the action. Now in the delete case here, we need to return our updated list of ingredients. So I'll take my current ingredients and then again use filter, run some logic on every ingredient and compare the ingredient ID with, let's say, the action ID. So I expect to have an ID field on the incoming action, which is the ID of the ingredient that should be deleted. And therefore, all ingredients where this is not equal should be kept. The one where it is equal will be dropped from the new list. And the new list is returned. What we return here replaces the old state. So that's our reducer, the reducer function. That alone doesn't do much. We now need to initialize it by calling usereducer, or utilize it by calling usereducer. Usereducer takes our reducer function, so the ingredient reducer in this case here, and usereducer also takes an optional sect argument, which is the starting state. And in our case, that's an empty array. So that's what will be passed in as current ingredients the first time this reducer runs. And for subsequent runs, current ingredients will be our current state. Initially, it's an empty array. And usereducer, like useState, returns something. That something also is an array, but now not with state and setState, but with state, so our user ingredients. So we can comment out this useState call here, user ingredients. But the second argument is now not a method to set our user ingredients. Instead, we're doing the setting in our reducer. Instead, it's a dispatch function. It's still a function which we can call, and you can name this whatever you want. The name dispatch is just one that makes sense because it's a function which you'll call to dispatch these actions later. So where you dispatch these action objects, which are then handled by the reducer. So I'll temporarily, again, still import useState so that the other code still works, but let's now utilize dispatch in the places where we previously called set user ingredients. Because we can't use that anymore, we're not managing the user ingredients with useState. Instead, here we now dispatch for setting the ingredients, and now here you need to dispatch an action. The action could be anything, could be a string, but typically it's an object, and here it's an object where we want to have a type property describing what action we want to do, and then maybe, depending on which action we're running, some extra data, like for setting our ingredients property here. So here, I'll dispatch an object with a type property. Type is set here. And of course, this has to be one of the identifiers you're handling in the reducer. So here it's the set identifier. And then this set action needs an ingredients property to work correctly. So here I add ingredients and set this equal to the filtered ingredients I'm getting. And with that, we're using dispatch to update our user ingredients. Hence now already, if we save this, this would work. But of course, we got two other places where we previously called set user ingredients. Like here, where we add an ingredient. We now instead call dispatch an action object where the type is add. Again, that's the identifier we're using in the reducer. And there we expect to get an ingredient property. So I'll add ingredient here. An ingredient is constructed as I'm constructing it here. So it's an object with my ID, and with the ingredient data I am getting here as an input to this function. So now we dispatch this. And finally, for deleting, instead of running this code, we also dispatch an action where the type is delete. Again, because we have the delete type here. And there I expect to get an ID field in the action object. You could have multiple fields. You don't always have to just have type and one other field. You can have as many fields in here as you want. Here, however, it will be the ID, and that will simply be the ingredient ID I'm getting here as an input to my remove ingredient handler. So that's now forwarded. With that, if we save this, this works. Our data loads. And if I add, for example, apples, that works. And to show that deleting also works, I'll fix that error in my delete HTTP request by adding that S again in JSON. And now if I click on, let's say, chocolate, this is removed and it stays away if we reload. So that's how we can use usereducer.